Welcome to this channel. This channel now grows to more than 120 videos, so that if you subscribe to the channel, you'll get the advantage of accessing all those 120 plus videos. So if you haven't done this subscription, it's time to do so now. So hopefully we'll see more people to subscribe this channel. Thank you. All right, today we're going to do a question in relation to area on the curve, but we need to find the intersection point between a straight line and an exponential function. This question is, we got several small questions, so we do one at a time. I already solved before I record this video, so if you look at my solution. So this is using graphics calculator to do a lot of calculation. So this is an exam paper, math exam paper 2 of 2021 VCE. So given the two functions, one is a qx, which is a log function. So we would need to find the equation of tangent. So this is a good practice to learn how to find the equation of tangent. So we know equation of tangent. Let's give you the formula. Y, if I got 2 points, then I can use that. So this is m is gradient, which is q dash x when x equal to a particular value. So now we need to find out the q dash 2, negative 2, sorry. So then we can be able to solve the straight line. So what I'll do is we're going to do this qx first. I derivative qx, so we easily to differentiate into that. So we're going to factorize denominator so that I can make common denominator. So the answer will be that. So now I substitute negative 2 into q dash. So the answer will be negative 1. So then I'm going to work out the 2 points, which is x1, like another points, so we can use for this formula. So we're going to substitute q negative 2 to original function. So we got the x is negative 2, y is 0. So therefore my function is, the tangent function is y equal to negative x minus 2. Okay, question 2, find the equation of a line that is perpendicular to Q. So if I want a perpendicular, that means perpendicular to the tangent. So I'm going to say initial, the Q function has the same point. We have the equation of tangent is y to a negative x minus 2. So L2 is perpendicular to L1. So two gradients must be equal to negative 1. So therefore M2 must be equal to positive 1. So then we substitute the same points to the equation. So we got the perpendicular equation is x plus 2. So this is the one I going to use for next question is, we got another function called px. So the new function px, which is exponential function. So we need to find a gradient. We don't want to find a tangent. We will just find a gradient of tangent. So at this time the x is a. So let's do the gradient equation. So we have derivative p, which is negative 2, etc. Don't forget it times by 2 e to the power of negative x. So substitute A, because you need to plug in A into the P dash X. So I'm going to take the common factor out. So that's it. That's the answer for D. All right, next question, we have drawn another graph. This the one is the px, which is the exponential function. This one is linear function, y to x plus 2. They join together at here, so we got an intersection point. But the angle between the two, one is a tangent, so we saw the tangent, the line and the tangent of graph, so form a acute angle. So acute means it's less than 90 degrees. So the angle is a 60. So this angle is a 60. We need to find a value for A. So first we know y to x plus 2. So therefore this angle alpha, this we call alpha, is 45 degrees because the gradient is 1. So tangent alpha is 45 degrees, alpha is 41, so the alpha is 45. So 45 plus 60 will be equal to beta, because the beta is exterior angle equal to the sum of the two opposite angles. So 105. So therefore, this gradient of this px, the tangent, sorry, gradient of tangent, which is gradient of the px, is equal to 105 degrees. So we can use graphical digital calculator to find a negative. Don't forget to use that. 3.73. So therefore, my gradient formula is already given, but we need to find an A. So we equal to A. So using GDC to get A is negative 0.67. So now, last question, we're going to find the area in green. So this is the green area. We need to find that this straight line, and this is the function of px, which is e to the power of negative x plus 2, e to the power of negative x plus 1. So we need to find that the area enclosed between the line, straight line, and this curve and the x-axis. So I shade in the green. So I'm going to divide it into two areas. So this on the left is area 1, on the right is area 2. So however, we need to decide what is the intersection point for the x. So we need to find the intersection point. So that's why we need an intersection. So when we find the intersection, we put these two together as a simultaneous equation. So this is equal to x plus 1. So we get that equation. So we can't solve it unless we use GDC. So make sure you use GDC to decide x is negative 0.75. So this the point is in the middle. So therefore, the total area enclosed area is equal to A1 plus A2. So A1 is from negative 2 to negative 0.75. The function is x plus 2. The next one is the area under curve of this is a px from negative 0.75 to 0. So then we're using the integration using GDC again, find the area 1, area 2, plus them together. So final answer is approximately 1.038 units a square. So that's it. That's the intersection point is important, but using graphics digital camera calculator to solve that. All right, thank you for watching. I hope you understand those questions. It's not hard, but there's a lot of small questions. So if you do, please give us thumbs up. I'll see you next time.